Okay, so I want to go over how to create Bohr diagrams with you today in case you are remote and at home and need some guidance. So a Bohr diagram is really just a model or a picture of an atom. And what it's really showing are how the electrons are arranged outside the nucleus on what we can call electron shells, orbitals, rings. There's a few different names for the area really outside the nucleus. We always start from the inside out, and there are some kind of rules we need to follow for how many electrons can fit on each shell. So I created a key on my slide 19, and I would suggest you do the same. On the first shell, we can fit a total of 2 electrons. On the second shell, we can fit 8. On the third, we can fit 8. And on the fourth, we can fit 18. Now, this kind of key really only works for the first 18 or 20 elements on the periodic table. Okay, so if we take a look at sodium first, we have a template for its Bohr diagram showing all the electrons and how they're arranged on the shells. And then right here, I have the atomic number for sodium. The atomic number tells us the number of protons and electrons in an atom of sodium. So that means we're going to be putting 11 electrons on these shells outside the nucleus. We always start on the very first shell closest to the nucleus, which is this one right in the center, and we can fit 2 electrons on this first shell. So that means we are going to fill the first shell completely, and we're going to have to move on to the second to continue putting the rest of our electrons, since we need a total of 11. So the second shell can hold 8. So this is my fourth one. 5, 6, 7, 8, 9, 10. So that's 8 on the second. So I've got 2, 4, 6, 8. So I've got 2 on the first, 8 on the second. I filled this second shell completely, and I have 10 electrons right now. So this still is not showing an atom of sodium because I need to show one more electron. But since I filled up this second shell completely with 8 electrons, I'm going to need to move to the third shell, and that is where I'm going to have to put my last electron to show sodium. So we have 1 electron on this last shell. It can hold up to 8, but that doesn't mean it has to hold 8. If I only have 1 more electron to put on to show an atom of sodium, then so be it. So to kind of write out the configuration, you don't have to do this. I just want to show you. We have 2 electrons on the first shell, 8 on the second, and we should have 1 on the third. So let's try potassium. Let me just grab one. Potassium has an atomic number of 19, so that means it has 19 electrons. 2 electrons are going to go on the first shell. We pretty much always fill up the first shell unless we have a really, really small element like hydrogen. So I filled up the first shell, so I'm going to move to the second shell. It can hold 8. So the first and second shell together hold up to 10. So that means I'm going to fill up the first and second shell completely. Okay, so I have 10 together. I still have to do 9 more. I filled up the second shell, so I'm going to move to the third. This one can hold 8 as well. So that would bring us, with filling all 3 of these shells, we would have a total of 18. So that means I will fill up this shell completely with 8 electrons. I like to group mine in pairs. I think it's easier to count them that way. So I've got 2, 4, 6, 8. So now I have 18. I need to show one more for potassium. So I've got 1 on this very last shell. And again, if I write out our little arrangement here, we've got 2 on the first, 8 on the second, 8 on the third, and 1 on the fourth. And that should give us a total of 19. Following the rules, right, using this key, with only having 2 electrons on the first shell, 8 on the second, 8 on the third, and up to 18 on the fourth. And that is how we create Bohr diagrams.